Example 3. Use the given factor and the factor theorem to find all real zeros for the given polynomial function. So we are trying to take this polynomial and break it down into all of its factors. And we're going to start by looking at x minus 2. So in the last video, we saw that if we were trying to divide by x minus 2, then the 0 that we would be considering is x equals 2. So let's use the remainder theorem and let's plug 2 into the function. 2 cubed plus 4 times 2 squared minus 4 times 2 minus 16. And just kind of verify, this will be plus 16 minus 8 minus 16. Verifying that we are getting 0 before we even start the division, because by getting 0 as a remainder, this tells me that, or by plugging 0 in and getting 0 out of the function, it tells me that when I divide x minus 2 into the original, I'm going to have 0 as the remainder. So it divides evenly. So next what I'll do is use synthetic division to break this polynomial down. So the 0 is 2, and we're dividing into this polynomial, and I'm going to look just at the coefficients. So I've got 1, 4, -4, and -16. All right, bring the first number down. That'll give me 1. Multiply, that is a 2. Add 6, multiply 12. Add down 8. And then we can see that, in fact, our remainder is 0. So rewriting the original, our original polynomial now is x minus 2 times, these are the coefficients of our new polynomial. This is x squared plus 6x plus 8. And we know how to factor that into x plus 4 and x plus 2. So this is really helpful if we're trying to graph this, because now we can easily find the 3 x-intercepts of the original polynomial. Let's look at another example. In this example, the factor is x plus 2, and that means that the 0 would be -2. Let's plug -2 into the function to make sure that it is going to, in fact, divide evenly. All right, let's see. This is 2 times -8. This is going to be a plus 4. This will be plus 10 plus 2. I'm getting -16 plus 16. Yeah, this is 0. So we know that this is going to divide evenly, so let's use synthetic division. So our 0 is -2. The coefficients are 2, 1, -5, 2. We bring the first number down, and then we multiply, and then add. 6, add down 1, -2, and yes, we're getting 0 as our remainder. So rewriting the original polynomial, we divided by x plus 2, and our new polynomial is 2x squared minus 3 plus 3x plus 1. And that can be factored into, let's see, 2x. Let me try this and see if this works. Maybe that's a minus also. Let's see. I would get 2x squared. This will give me a positive 1. And then my middle term will be a minus x and a minus 2x. Yes, this is correct. I'm just double checking that that's correct. So this is our completely factored version. All right, one more example. For this example, the factor that we're looking at is x minus 3. So the 0 is equal to 3. Let's plug 3 in to verify that it gives us 0. Let's see, 3 cubed, 16 times 3 squared, minus 9. 3 cubed is 27. 16 times 9 minus 9. What's 5 times 27? Negative 135. And then this is 16 times 9, 144. Yeah, that's 0. Okay, so then we'll do synthetic division. The 0 is equal to 3. And then the coefficients are negative 5, 16. We don't have x to the first power in our original polynomial here, so we'll put a 0 as a placeholder, and then negative 9. So when we add, bring the first number down and then multiply, add down, we'll get 1, 3, 9. So our remainder is 0. So our original polynomial now is x minus 3 times negative 5x squared plus x plus 3. I want to try to factor this, but I don't think it's going to be factorable. One thing that makes it a little bit easier when you have something like this is to bring the negative sign out into the front. So I'm going to take a negative 1 out of all of the terms here, because it looks like I'm going to have to use the quadratic formula. So I just brought a negative 1 out of all of those terms that were here. All right, so let's do some side work. X equals negative b squared minus 4ac all over 2 times a. For us, a is 5, b is negative 1, and c is negative 3. So negative 1 will be positive 1. This will be 1 minus 4 times 5 times negative 3 all over 2 times 5. So I'm getting 1 plus or minus the square root of 61 over 10. All right, again, our goal is to find the zeros. So I've got 2 zeros over here. The factored version is going to look a little bit funky. Let's see. I'm going to bring the negative 1 out into the front. And then I'll have, all right, this is going to look, I'm going to have x minus, one of my zeros is 1 plus the square root of 61 over 10. And the other one, let me move this over a little bit, is going to be x minus 1 minus the square root of 61 over 10. Again, if we were going to graph this, what we would do is we would plug this into the calculator to figure out what the decimal approximations are. But this is just a way for us to completely factor something. We're expecting to get possibly 3 zeros because the original was raised to the third power, and we are getting 3 zeros. One of them is a number that we know, x equals 3, and the other two are decimal values.